Well, hello guys, welcome back to Mr. G Physics, the channel that can help you to improve your mark in physical science. Still Mr. G, and this time we're going to be solving a question on projectile motion for the grade 12. If you didn't subscribe yet, don't forget to subscribe so you can get the notification of all the videos I post on regular basis. This question says ball A is dropped off the top of a cliff. Since the moment they say drop, remember it means is initial velocity is equal to 0. That is an important point there, which is 57.5 meters high. The height of the building is 57.5, and I'm going to write it on this point here, this height here, not exactly up until there, rather up until this point here. It's going to be 57.5 meters. Okay, at the same time that ball passes point Q, when ball A is at point Q, when ball A is here, let's write here ball A. When ball A is there, which is 16 meters below point Q, it means that from P to Q, this distance here is going to be 16 meters. All these are important data. Okay, this one is 16 meters. Maybe we can write it with another color to differentiate. This distance here is 16 meters. Important data as well. A second ball B of 0.2 kilogram is thrown downward from the same height. So ball B, at that point, ball B is thrown downward. Okay, it is being thrown when ball A is there from the same height. Ignore the effect of a friction. Question 3.1: is ball B in free fall? Only write yes or no and explain your answer. So what will the answer be for 3.1? And let's answer at this side here. 3.1, yes, it is a projectile, because the only force acting is gravitational force. Alright, there is 2 marks for saying that. Question 3.2: calculate the time it takes for ball A to fall from P to Q. Okay, so let's answer that question here, and let's write data. This is question 3.2, and let's see what data we have. First of all, we're going to write down as positive. We're going to write down as positive because the whole motion is down, so it's not reason to write up positive. Then what we have? We have that the initial velocity is equal to 0. We have that acceleration due to gravity is equal to positive 9.8 meters per second square. We have that we are looking for the time. It is an important data here. And we have the displacement, which is 16 meters. They're asking you for that distance between P and Q. That is what they ask you here. Alright, so here is all the data we have, and remember to go to the formulas. So if you go to the formulas, which one is the one you can use here is the formula you can use, and this size here we have all the data for that formula. So now we write the formula and we substitute. Let's write the formula. Displacement is equal to initial velocity multiplied by the time plus half acceleration multiplied by the time square, and then we substitute. Answer is equal to 1.81 seconds. Okay, so this one is quite simple. All right, now in terms of mark, you get 1 mark for the formula, 1 for the substitution, and 1 for the final answer. It's quite simple to get these 3 marks. Now here is an interesting fact that we carry on. Both balls reach the ground at the same time. Ball B is in contact with the ground for 0.02 seconds from where the bounces back with a velocity of 20 meters per second. So an important fact is that both of them reach the ground at the same time. However, it was less time for B than A. B was 1,81 seconds less than 8 because B was thrown only after that time here. So what we are going to do here, we're going to calculate the total time for A. And remember B, it takes 1,81 seconds less because it was thrown always after that time has passed. Okay? So let's answer this question here, question 3.3.1. Let's write data again here. We have the initial velocity for the whole motion we're going to use downwards positive, guys. We're going to calculate the total time for ball A. That's what we are going to do here. So what we have, same data. The displacement in this case, we didn't write it. Displacement is going to be equal to 57,5. That is the height of the building. That is the displacement, positive as well. Okay, so here's all the data. What formula we're going to use? We are going to use the same formula, and we have everything, guys, so we substitute. And we get that the time for A is equal to 3,43 seconds. That is the total time for ball A to reach the ground. Now what happened about ball B? And this is important. Time B will be equal to time A minus 1,81. Because 1,81 is the time that already was ball A in the air when ball B was thrown. So that is the thing here. Time B will be equal to time A, this one is A here, minus that 1,81 seconds. Therefore, what is the time B to reach the ground, the total time for B to reach the ground? Let's calculate it real fast here. Let me get here the color. There we go. Time B to reach the ground is equal to 3,43 minus 1,81. And we get that the time for ball B to reach the ground is equal to 1,62 seconds. That is the time for ball B to reach the ground. Now, the question asks us to calculate the velocity for ball B. What data we have? We have the same data. Let's write data here for B. Okay, so what we have, initial velocity we are looking for. All right, we have the acceleration due to gravity is positive 9,8 meters per second square. We're taking down as positive still. We have the time for ball B is equal to 1,62 seconds. We have the displacement. The displacement is equal to 57,5 meters positive, and that we have everything. So what formula we're going to use, guys? We're going to use the very same formula here. So we're going to use that formula. Let me just write it down here, and then we substitute all the data we have here. And then the final answer is equal to 27,56 meters per second. It's a very good question, this one, guys, because you have to work with two balls. Okay, so let's see the marks here. It's always good to get to know where the marks are located. There is one for writing this formula as well as for the substitution in terms of calculating the time. There is one mark for calculating this or substituting this time B. For the subtraction, there is one mark. There is one mark for this substitution here, as well as one mark for the final answer. And that is this question. Is a very good question. And then to continue here, the question 3.3.2 say calculate the speed of the ball just before it hits the ground for the first time. And now we have everything. This is question 3.3.2. The data is the same. We are not going to rewrite. The only new data is the initial velocity. Now we have it, which is 27.56 meters per second. Everything is positive here because the object is moving down. So I'm not going to write the data again. But the formula, which one can we use, guys? We can use this first formula here. We have everything. So we come here, we have that the final velocity is equal to initial velocity plus acceleration multiplied by the time. If you don't write G, instead you write A, you will be absolutely fine. So now we substitute. We're looking for the final velocity. And we get that the final velocity of the object is equal to 43.436 meters per second. They ask for speed, and speed is in scalar quantity, so no direction needed. Here's the question. There is the answer without direction. Okay, so now what does the question continue? The question is quite long. All right, the question say now calculate the force that the ground exerts on the ball so that it can bounce back. And for this one we have to use Newton's second law in terms of momentum. So let's add a page here and then solve that question real fast. Now for that question we need again data. They're looking for the force that the ground exerts on the ball. That is the question here. So we go back all the way because some data are important here in the question. The question is here. Note that they say that it was 0.02 seconds in contact with the ground and it bounces back with 20 meters per second. So in this case, we have that the time in contact with the ground here, time in contact is 0.02 seconds. We have that the final velocity is equal to minus 20 meters per second because it's upward. In this whole question, in the entire question, we took down as positive and we're going to keep it like that. Alright, and the initial velocity is the one we just calculated. This one here is final for the first question, but now it's initial for this one. That is the velocity with which that ball reaches the ground. So it's going to be positive 43.436. And we have now everything. There we go. So what is Newton's second law in terms of momentum? That states that the net force is equal to the rate in change in momentum. There we go. And now if we break this formula further, we have that is mass bracket final velocity minus initial velocity divided by the time, guys, and the rest is to substitute because we do have everything here. Let me just write the symbol of vectors there. There we go. And we have everything, so the rest is substituting. Note we didn't write the mass of the ball. Mass of the ball he is given to us in the first part of the question, 0.2 kilograms. Okay. And the answer here for F net is equal to negative 634.36 Newton. That negative mean upward because we said down is positive. So the net force, let's write it, the final answer like this, 634.36 Newton upwards. That is the final answer for this question there. We're almost done, guys. This question is quite long. When you give marks, it's one for the formula. It doesn't matter which one you did right there. You'll get the mark. It's 1 mark for the substitution. Let me see. On the numerator, 1 for the denominator, and 1 for the final answer. Okay, that is the answer for this question. We almost done, guys. We almost done. Now the question say. Next question, what is the magnitude and direction of the acceleration of the ball while it moves upward after bouncing back? And then when it's moved back, it's a projectile once more, so it's equal to 9,8 meters per second square downwards. Alright, I'm going to write down. You can write downward there, and you get 1 mark for saying that one. The part down, direction is very important. And then the final part of the question, draw a velocity time graph to demonstrate the movement of both balls A and ball B from the moment ball A is released till both ball A and B hits the ground for the first time. Show the following in your graph. And then you have to give the initial velocity of ball base, final velocity of ball B, and the relevant time values. So let's go down here and draw the graph. It's up until they hit the ground, so we don't have to think of the bouncing of ball B. Alright, so we're going to start with the axis. Alright, and we are going to take also down as positive. In the whole question, we work with down as positive, and we are going to keep that one. So let's focus on ball A first. Ball A begins to move from 0. There is the origin, that is 0. So it moves straight line all the way up until it reaches the ground. We don't have that velocity, but we know that it took for that ball to reach the ground 3,43 seconds. That time we know it. This one is ball A. Alright, now ball B did not begin from 0. It started from some point. So ball A started with an initial velocity that is different from 0. For instance, let's draw it here, and it's 27,56 meters per second. It was calculated. Move all the way. This one was already, the time was the 1,81. That is when ball B start moving. So from here, ball B start moving, and ball B move, remember, parallel to A. Why it must be parallel? Because the gradient is the same and will stop at the ground here. What is the value of the velocity of ball B when it reaches the ground? We just calculated here, and it was 43,434. That was the value of the final velocity of ball B. The time is the same. This is ball B. Once more, I want to point the lines are parallel because have the same gradient. What is the gradient? The acceleration due to gravity. That is the gradient here. Guys, saying that this is the final part of the question is quite interesting here. The marks here allocation is tricky, so I'm not going to speak about the marks for the graph. This is the shape of the graph, and this is all. Thank you for watching. The question is a little bit long. I'm really sorry about that, but I'll see you next time. Mr. G here.